Alright, 6-8, graphing these radical functions. Kind of a break from the usual routine here with some of these other units, right? Usually these other units that we've been working on, we've been graphing first, and then factoring, and then solving. Now it's kind of been the other way around. We solved a few, and now it's time to graph them. So let's get a good understanding of about where radical functions come from, how we get them, and some very easy ways that we can go about graphing them. Now, the nice thing about what we're going to do here is terms of time constraints and in terms of just depth of knowledge that we really need to get to as far as Algebra 2 students are concerned is we're only going to focus on square root functions and not necessarily other root functions. Okay, so the square root function, where it comes from, it's actually the inverse of a quadratic function with just a restricted domain. Here's what we mean by that. Picture a quadratic function, f of x equals x squared, to get that perfect looking parabola just like that. Okay, now what an inverse function is, and if you're interested in really reading about inverse functions, I suggest you take a look at section 6-7, which really I would love to be able to have the time to go over that with you guys. If we do have some time, it'll certainly help looking at that section when we get back into January when we start Unit 7. So if we have some time, I'll probably work that in there a little bit and look at 6-7 with the rest of you. But when it comes to this section here, an inverse function pretty much reverses the roles of x and y. And so what you're looking at right there, when you take an inverse function, in other words, do the inverse operation of x squared, you end up with the square root of x. Here's the problem. When you solve and get an inverse function, by the way, there's the notation for an inverse function, f to the negative first power. What we get here not only is the positive case, but the negative case as well. But do you see that when we take this parabola and turn this guy sideways, it fails the vertical line test? That's no good. So what we can do to a square root function to actually make it a function is actually to restrict the domain. And if I restricted that parabola to just the right side of that parabola, and we do the same thing. We don't look at the negative case of the square root function. Instead, we look at the positive case of the square root function. There we go. And there's our parent function for the square roots. Notice a couple of key points right here. The square root of 0 would be 0. If I go to 1, the square root of 1 would be 1. The square root of 2 is a decimal. Square root of 3 is a decimal. But then when you hit the square root of 4, you hit precisely 2. Okay? And so then what you're looking at right down here is that family of square root functions. There's the parent function, y equals the square root of x. If you want to do a reflection, just put a negative sign in front of that x. Hey, make sure you put that negative sign in front of the x, because if you put it inside the square root, now you have imaginary numbers. That's no good. And then if we want to do a stretch or compression, there's a. And then if we want to do horizontal and vertical translations, boy, have we seen something like this before? Boy, have we seen this before. We saw it all when we were dealing with quadratics. It just looked like this, didn't it? Right? Where we were doing stretch, compression, and reflections right there. This was moving the graph left and right, and up and down. The only difference now is that now we're doing it with square root functions. Okay? So that's pretty much it. And so the next problem just gets us to focus on just one transformation at a time. So let's focus on one transformation at a time, and let's worry about just translations. So problem number 1, let's take the parent function and let's translate this function vertically. Now, to do a vertical translation of a function, just like we did with quadratics, vertical translations, that's that k business right there. What's so special about k, and what makes k different to indicate vertical change as opposed to horizontal change with h right there? See how k is outside, in other words, takes place after the square root parent function takes place. So if we have addition or subtraction after the square root function, which we do in both these two cases, it's going to take that parent function and translate everything up or down that amount of units. So that first one, y equals the square root of x first minus 2. Right here, that dashed line right there, there's your parent function. Okay, let's highlight a couple of key points there. Key points there, put it here in green. There's the square root of 0 is 0. The square root of 1 would be 1. The square root of 4 would be 2. Notice that you can even make it all the way out there to 9 and get the square root of 9 to actually be 3. Okay, and so when we have the square root of x minus 2, it pretty much just takes all of those key points, all of those green ones that we have right there, and takes them and moves them down 2, down 2, down 2, down 2. And there's that new graph right there. We can connect those and make that graph. The same thing happens here with this guy. We can describe the transformation with x, the square root of x plus 1, moves it up 1, up 1, up 1, up 1. And there we have that graph. So pretty straightforward, isn't it? I like these. This graph should not be too hard to make then for each one of these. Okay, so here's what I'd like us to do. Let's go ahead and graph both of these two on the exact same coordinate plane. So I'll pause it for a little bit. Go ahead and graph. Ooh, do me a favor first. Could you please graph the parent function? Graph the parent function for me and put that on that coordinate plane. Okay, now parent function, put that, and then also do me a favor, could you make that dashed? Just like that one that you see right there. That way we can separate it from the other ones. Okay, so go ahead and do that dash parent function first, then move on to the next one. And the only reason why you see a blue and a red right there is that way you can see the difference when I start filling in the correct answers here. Okay, so let's go ahead and take care of that. Let's graph the square root of x plus 2, and then after that graph the square root of x minus 3. Okay, let's pause it, give yourself some time to graph. Alright, so that parent function, graphing those points in there, the square root of 0 would be 0, square root of 1 would be 1, and then the square root of 2, since it's a decimal, go ahead and skip it. And square root of 3, skip that one. Square root of 4, we can graph that one in there, and then there's your parent function, just like that. Okay? Now, let's move on to y equals the square root of x plus 2. What transformation should take place there? Shouldn't we be taking this function and doing a translation up 2 units? So then that's a pretty easy graph to make. If we have that parent function made, we're just taking all those points and just moving everything up 2. So that one moved up 2, moved up 2, moved up 2. And then there's that graph. Okay? There's y equals the square root of x plus 2. Square root of x minus 3, you got it. We're moving everything down 3. So from the parent function, dot, 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 graph, great. So when it's just like that, pretty easy there. And by the way, these are super easy to check with your graphing calculator as well. The only thing you'd have to be very cautious about is how you end up typing this in, because you could type this in incorrectly here. Take a look at the first one. If I type in the square root of x, and that was plus 2, what happened to our graph? Wasn't it going up 2 units? Take a look at what the graph did. Hey, whoa, wait a second. Why did it go to the left 2? I think you know why. Yep, because we told the calculator that, didn't we? That's what the calculator sees. So how do I fix that problem? You got it. We got to put a parenthesis right there to say now just the square root of x and then plus 2. So a lot of students make mistakes with that and routinely make that mistake. So make sure you don't make that same mistake twice. Okay? And then we could follow it up with another one. Square root of x, close the parenthesis, minus 3. And there it is. That graph got moved down 3. Okay? So lesson learned here, make sure that if the square root is, if there's a vertical translation going on, make sure you close off that square root with the parenthesis and then do your addition subtraction after that. Okay? Let's move on to the next problem with the next video.